Welcome students, we have been given this question 3 raised to the power of x divided by 1 positive 3 raised to the power of x is equal to 2 over 5. We are expected to calculate 81 raised to the power of x divided by 1 positive 81 raised to the power of x. And there are two different methods to do the same question. The first one is long and cumbersome, but the second one is very snappy. In other words, if you were to adopt the second method, you will be able to obtain the solution probably in 20 seconds. But I would like to show you the first method so that if in case you have some situation because of the question, maybe you can adopt this first method. So now let me just start off with the word consider. Consider 3 raised to the power of x divided by 1 positive 3 raised to the power of x is equal to 2 over 5. Now I would like to take 3 raised to the power of x to be equal to some p. So if I were to name it as 2, therefore I can rewrite 2 to be as p divided by 1 positive p is equal to 2 over 5. I cross multiply these terms, I will get 5 times p is equal to 2 times of 1 positive p. This is 5p is equal to 2 positive 2p. I move the 2p to the left and that would give me 5p negative 2p is equal to 2, which means 3p is equal to 2. Therefore the value of p is equal to 2 over 3. So this is the value I have got. So now what I'm going to do is I'm going to consider the question 81 raised to the power of x divided by 1 positive 81 raised to the power of x. I can rewrite 81 as 3 times 3 times 3 times 3. So that would mean the numerator is going to be 3 raised to the power of 4. That has to be raised to the power of x, followed by 1 positive 3 raised to the power of 4 raised to the power of x. Now from the law of indices, if I've got something like this, a raised to the power of m raised to the power of n, I can rewrite it as a raised to the power of n raised to the power of m. Of course, I can also rewrite it as a raised to the power of m times n or a raised to the power of n times m. So there are different ways by which we can write once we know them to be as proper indices. So now what I'm going to do, I'm going to rewrite 3 raised to the power of 4, the old raised to the power of x as 3 power x raised to the power of 4 divided by 1 positive 3 raised to the power of x raised to the power of 4. But I have taken 3 raised to the power of x to be as p. So this is going to be p raised to the power of 4 divided by 1 positive p raised to the power of 4. But my value of p is 2 over 3. So this is going to be 2 over 3 raised to the power of 4 divided by 1 positive 2 over 3 raised to the power of 4. So 2 power 4 is going to be 16, 3 power 4 is 81, this is going to be 1 positive 16 over 81. So I can rewrite this as 16 over 81 divided by, if I were to take 81 as the LCM, this is going to be 81 positive 16 divided by 81, which is 16 over 81. If I flip this, I would get 81 over 97. 81 can be cancelled, giving me 16 over 97. Which is the solution to the question 81 raised to the power of x divided by 1 positive 81 raised to the power of x. Now the point comes here is this involves too many algebraic steps, and we should also be aware of the certain laws of indices. Even over here you should be aware how to perform the flips using the algebraic property. In this case I'm using, if I were to be given a over b divided by c over d, then I can rewrite it as a over b times d over c, right? Now instead of doing all those things, the method 2 gives us a nice way. Now just take the question. The question is 3 raised to the power of x divided by 1 positive 3 raised to the power of x, which is equal to 2 over 5. Now just consider the numerator, it's 3 raised to the power of x. Consider the denominator. The denominator is nothing but 1 more than the numerator. So that is an important observation. So as I always mention, observation is a critical point in mathematics when it comes to problem solving. Now what I wish to do is perform the same observation for the numerator. The numerator is 2 here and the denominator is 5. So that would mean the denominator on the right hand side is actually 3 more than the numerator. So that's a very important observation when it comes to the right hand side. Now what I'm going to do, I'm going to take this 3 and I'm going to divide the numerator, and I'm going to divide the same with the same quantity, the denominator, for the right hand side. So that's going to be 5 over 3. In fact, if you were to observe, I have not done any changes at all, because the 3 that I used to divide the numerator and the 3 which are used to divide the denominator, they get cancelled. But what is more important is the untold story that the 3 can bring about, which in this case is as follows. So I can rewrite the numerator as it is 2 over 3, but when it comes to the denominator, I'm going to write it as 1 positive 2 over 3. So now what have I done? Now my denominator, which is on the right hand side, let me represent it like this, dr of h of s, is nothing but 1 more than the numerator, which is what we have observed on the left hand side. So on the left side, I've got 3 raised to the power of x divided by 1 positive 3 raised to the power of x. So all I need to do is equating the left hand side with the right hand side we get. So what do we get? I get 3 raised to the power of x is equal to 2 over 3. So that is the solution I get. However, since I got 3 raised to the power of x is equal to 2 over 3, therefore I can write 81 raised to the power of x divided by 1 positive 81 raised to the power of x as 3 raised to the power of 4 raised to the power of x divided by 1 positive 3 raised to the power of 4 raised to the power of x, which can be rewritten as 3 raised to the power of x raised to the power of 4 divided by 1 positive 3 raised to the power of x raised to the power of 4. My 3 raised to the power of x is 2 over 3. We have to raise it to the power of 4 divided by 1 positive 2 over 3 raised to the power of 4, which upon simplification will give me the same 16 over 97 as my solution. Now the all important point is 3 raised to the power of x equal to 2 over 3. Is that the only solution? The question is this the only solution? Right? In the first method, there is no such assertion that 3 raised to the power of x is equal to 2 over 3 is the only solution. In fact, there has been no room for that at all. We can just find the value of x using that simple algebraic technique. But to make sure that 3 raised to the power of x is equal to 2 over 3 is the only solution, is that penultimate point that has to be taken into consideration. So that one would completely finish the problem off from top to bottom. So that is our objective. So I'm just going to show you that. So now what is given? We've been given that 3 raised to the power of x divided by 1 positive 3 raised to the power of x is equal to 2 over 5. So I'm cross multiplying it, and then I'm going to write this as 5 times 3 raised to the power of x is equal to 2 times of 1 positive 3 raised to the power of x. Now just observe the left hand side. This is a strictly increasing function, right? Now observe the right hand side. This is also a strictly increasing function. Okay, now if these two functions were to meet, because of the fact that they have been given like that, 3 raised to the power of x divided by 1 positive 3 raised to the power of x is equal to 2 over 5. Now if these two strictly increasing function were to meet, then they would meet at just one point. That's it. Just at one point they will be able to meet. I shouldn't use the word able to meet. They will meet. And that one point is 3 raised to the power of x is equal to 2 over 3. In other words, telling it in algebraic term, 3 raised to the power of x is equal to 2 over 3 is the only solution to this question. So why this method 2 is so important, or I would say it's so unique, because it gives us the ability to conclude that the solution that we have got is the penultimate one. and there exists no other solution. Thank you students, enjoy it.